So section 5.2 deals with solving quadratic equations by graphing. So last section we looked at graphing quadratic equations. Now we're going to look at actually using those graphs to solve those quadratic equations. So first we need to define a quadratic equation. So a quadratic equation is just your quadratic function actually set equal to some value. And for our purposes we're going to talk about the quadratic equation in what we call standard form. And if it's in standard form, then that equation is set equal to 0. And you'll see it in the form of ax squared plus bx plus c equals 0. Remember, these terms have those special significant meanings that we talked about in the last section. So we can solve these types of equations when we have an equal sign and it is set to some value. And we can start off by knowing that we're going to have 3 possible solutions to any quadratic equation. We're either going to have a situation or a system where we have one solution, and that's going to be where one point, your vertex of your quadratic, is actually on the x-axis. Another possible set of solutions you might have is 2 solutions. And you'll see that's where your arms of your parabola are actually going to cross the x-axis. We can also have a situation where we have no true solutions. And this is where our parabola does not touch the x-axis at all. In fact, we'll never cross it, and it's floating in one of our quadrants. So another name for the solutions of a quadratic equation is the roots. And you'll hear me use these terms intermittently or for one another. I will replace them for one another. So again, the solutions of a quadratic equation can also be known as roots. And any quadratic equation may have one root or one solution, 2 roots or 2 solutions, or no roots or no solutions. Let's try some examples. Here we have an example of solved by graphing. So given the equation x squared plus 6x plus 8 equals 0, we want to try and solve this by graphing. So we know we have 3 possible scenarios, right? We may have 1 solution, 2 solutions, or no solutions. Okay, so I know that's what I'm looking for. I also want to start looking at some pieces of my equation. So ax squared plus bx plus c equals 0. Remember, this a, b, and c terms give us some special information about our graph. So our a value would be 1, our b value would be 6, and our c value would be 8. And if you guys remember from what I told you last time, the vertex x is going to be negative b over 2a. And that's a great place for us to start because our parabola is going to branch off symmetrically from that point. So plugging in my values for my vertex x, I'm going to get negative 6 over 2 times 1, which equals negative 3. And I can plug that value now into my table to start generating values for y. So if I plug negative 3 back into my equation, I'll end up with negative 1. Negative 3 squared is 9, 9 plus negative 18 is negative 9, plus 8 is negative 1. I know it goes up symmetrically from that, right? So I'm going to start choosing values on either side of that x. So let's go with negative 4, negative 2, negative 5, negative 1. Okay, we can choose more than that, but let's at least go to 0. Okay? So now just start plugging in. Negative 4 squared is 16, minus 24, plus 8. We have 0. Okay? And if I plug in negative 2, I also am going to get 0. Right? Because it's mirroring over on the other side. What if I plug in negative 5? Negative 5 gets me 3. So negative 1 should also get me 3. And if I plug in a value of x for 0, it's higher and way off my graph. You guys should get some crazy value, something really high, right? 8 or something. Okay, but given this information now, I can set my graph. So graph your vertex x first. Negative 3, 1. negative 3, negative 1, negative 4, 0, negative 2, 0, negative 5, 3, and negative 1, 3. And we can draw in our graph. So the possible solutions of this equation then would be 2, because we're looking at where it crosses the x-axis, and it's going to be x equals negative 2 and x equals negative 4. And that would be our solution set for this equation. Yes, John? Here we have another example of a quadratic equation that we can solve by graphing. It doesn't look the same as the last one because it's not in standard form yet. So first thing we want to do always is get our equation into standard form. That makes it easier to graph. So what I want to do is subtract 16 from both sides. That sets it equal to 0, so at least I am one step closer to standard form. And then I like to rearrange so that my variables are in the right order. So I'm actually going to be working with negative x squared plus 8x minus 16 equals 0. So now that I have my equation, I want to identify my a, b, and c. So a is equal to negative 1 this time. B is equal to 8, and c is equal to negative 16. Now last time our a was a positive value, and our graph went like this. Okay, so this time our a is a negative value, which indicates that our graph is going to go upside down. Okay? The other thing we want to find is that vertex x. So again, my vertex x is going to be negative b over 2a, which gives me negative 8 over 2 times negative 1. Which gives me negative 8 over negative 2, which is equal to 4. So this time my vertex x is going to be 4. So now I can start generating my table of values. And I'm going to put it in the middle this time. Maybe that'll help with the visual. Okay, and then we're going to go up 2 and down 2. And we're going to plug those in. So if I plugged in my vertex x of 4 back into my original equation, I will get 0. Okay? And if I plug in 5 back into my original equation, I get negative 1. And if I plug 6 back into my original equation, I get negative 4. What do you think is going to happen down here? Same thing. I can cheat because I know the rule. They're symmetrical. Okay, now that I have these points, I can graph. We'll start with 4, 0. Then we'll go to 5, negative 1, right? Because we already said it's going to go down. And 3, negative 1. And 6, negative 4. And 2, negative 4. Connect our dots. Okay. How many solutions for this one? 1. It only crosses the x-axis one time. And our solution, x equals 4. Okay, now we can try one where maybe there's no solutions, or at least no real solutions that we know of. So let's try and solve by graphing this equation. Negative x squared plus 6x minus 10 is equal to 0. Okay? So the first thing we want to do, find a, b, and c. So a equals negative 1, b equals 6, c equals negative 10. So my vertex x, negative 6 over 2 times negative 1. Negative 6 over negative 2, positive 3. Start making your table of values. I know I'm going to be symmetrical on either side, so I can go up and down. And I can plug in some values. So if I plug in x equals 3, I get -1. If I plug in x equals 2, I get -2. If I plug in x equals 4, I get -2. If I plug in x equals 1, -1 squared plus 6 is 5, minus 10 is -5, and -5. Okay, are we seeing maybe that it might not cross the x-axis? So we start with 3 -1, and then go to 4 -2, and 2 -2, and 1 -5, and 5 -5. And it's just floating, right? So no real solution. So far, all the examples we've seen have been really concrete. We've gotten whole numbers, or at least integers, as our solutions, as our roots. Sometimes it's not always so clear, and we actually have to estimate, because the place where it crosses the graph will actually be somewhere between two integers, okay? So, for example, let's try solving this by graphing. -x plus 4x minus 1 equals 0. Again, first thing we want to do, identify A, B, and C. So A is -1, B is 4, C is -1. Next thing you want to do is find your vertex x, which is -b over 2a. So we have -4 over 2 times -1. -4 over -2, positive 2. So now I have my vertex x. Set up your table. So now I'm going to go up and down. Okay? So let's plug in 2. We plug in 2, we get 3. If we plug in 0, we get -1. If we plug in 1, we get 2. And we're pretty sure these are going to follow on the other side. Okay, so now let's try and graph it. So 2, 3. Okay. And 1, 2. And 0, -1. Okay. And then 3, 2. And 4, -1. So if we look at our graph, where do the roots actually lie? They lie between 0 and 1 and between 3 and 4. So the solutions would be just that, between 0 and 1, between 3 and 4. That's if you're doing it by graphing. Obviously, if we solved it mathematically, we could come up with solutions. But by graphing, you can estimate and use the words between one and another.